This video is going to be about the Pythagorean identities. An identity is something that is always true. So these equations that we are going to see are always true. Something at its most basic might be x equals x. That is always true. An example that wouldn't be an identity is something like 3x equals 9. This is only true when x equals 3. If x equals anything else, it's not true. But with x equals x, that's always true, no matter what x is. The first Pythagorean identity you worked with today in class, if you take the sine of an angle and you square it, and then you add the cosine of an angle squared, that will always be 1. We wrote it like this top equation in class. Generally, you will see it written like the second equation. The square, the 2 between the sine and the theta, means take the sine first and then square it. So let's just go through a quick example to prove this is always true. So I want to prove this or show it when theta equals 50. So I'm going to do the sine of 50 and then square it, and then add the cosine of 50 and square it. So I used a calculator to find the sine of 50, which is 0.77, and then the cosine of 50, which is 0.64. I then squared both of these numbers, also using my calculator, and I got 0.59 plus 0.41, which is, in fact, 1. Now let's look at how this identity can help us solve something. So in this example, you're given the sine of an angle is 0.43, and we're asked for the cosine of the angle. Notice we are never asked to find the angle. We don't care what the angle is. So I'm going to replace, using my Pythagorean identity, I'm going to replace the sine with 0.43. So 0.43 squared plus cosine theta squared is going to equal 1. And now I can just solve for cosine. So I'll square 0.43, and I get 0.18 plus cosine squared theta equals 1. Now subtract 0.18 from both sides, and I have that the cosine squared of this angle is 0.82. Now all that's left to do is take the square root of both sides, and I'm left with the cosine of the angle equals plus or minus 0.91. Oops, the cosine, not the cosine squared. Notice that I put this plus or minus in front. When you take the square root, you have to remember to put a plus or minus. And let's look at why that is. Remember that the sine is the y on the unit circle. So if this is 1 on the y, 0.43 might be somewhere right around here. So there are actually 2 places that might have a sign around 0.43. We'll have a positive 0.91 for cosine and a negative 0.91 for cosine. And that's why we get 2 answers. Now I'm going to do another example. This time we're given cosine of an angle, and we're asked to find the sine of the angle. Again, we do not care what the angle is. We're only looking for the sine. So I have the sine squared, the angle, plus the cosine, but I'm going to put this in, so negative 0.8 squared equals 1. So sine squared of an angle plus, now because it's a negative square, that actually becomes positive, so plus 0.64 equals 1. Subtract 0.64 from both sides. Whoops, not 4, 6. 6, 4 minus 0.64. So I'm now left that the sine of my angle equals 0.36. Sine squared equals 0.36. Now I'm left to square root both sides, and you can use your calculators here. But the sine of my angle is going to equal 0.6 plus or minus. So those are my two answers. Now you may have noticed that I titled this video the Pythagorean identities, but we've only seen one. So now I'm going to show you how we can use this one identity to actually get two more identities. So notice I've written the same thing twice up here at the top. It's because I'm going to use one to find identity 2 and the other to find identity 3. So let's start on the left. I am going to, just for fun, divide everything in here by cosine squared. Just for fun. And then I'm going to go through and simplify it using other things I happen to know. The easiest one to see here is that cosine squared theta divided by cosine squared theta, that's just going to become a 1. So we're going to end up with a plus 1 right here. Now, sine squared over cosine squared, if you remember back to the unit circle, sine over cosine was tangent. So sine squared over cosine squared is just tangent squared. And then 1 over cosine, well, that's the reciprocal of cosine, which you know is the secant. So this actually is going to give us our second identity. The tangent of any angle squared plus 1 equals the secant squared of that angle. That will always work for any angle. Now I bet you can guess at this point what I'm going to do in the second one. Instead of dividing by the cosine, I'm going to divide everything by sine squared and then simplify. So it's going to be pretty similar. Sine over sine, sine squared over sine squared changes into a 1, so I have 1 plus. Now cosine over sine, notice that's the reciprocal of sine over cosine. So that's going to turn into cotangent squared, which there was the reciprocal of tangent. And then 1 over sine squared, well, that is the cosecant squared. So let me write that better down here. We have 1 plus the cotangent of any angle squared equals the cosecant squared of that angle. And so now we have 3 identities. Now I'm going to do a quick example using this identity number 2. This is probably the second most common one you'll see. We'll focus on that and the first one. So this time I'm told the tangent is 1.5 and I'm asked for the secant. So let me just use my identity. I know that the tangent squared plus 1 is the secant squared. So I'll do 1.5 squared plus 1. That should equal the secant squared of the angle. So now I need to go to the calculator. And 1.5 is 2.25, 1.5 squared, plus 1 equals the secant squared. 2.25 plus 1 is 3.25, equals the secant squared. Now I want the secant, not the secant squared, so I've got to square root it and go back to the calculator. And the calculator is going to tell me that the secant of theta is going to be plus or minus 1.80. Again, notice 2 answers. Always be on the hunt for 2 answers. All right, one last example. I know these are getting pretty repetitive. This time I am told the secant and I want the tangent. So tangent theta squared plus 1 equals 3 squared. Well, that one I know in my head. Tangent squared plus 1 equals 9. Well, to get tangent by itself, I need to subtract 1 from both sides. So tangent theta squared equals 8. Now square root both sides. So I'm left that the tangent of theta, and I'm going to use my calculator to estimate, is approximately 2.82 plus or minus at the front. And I'm done. All right, now your classwork for Tuesday, May 20th is going to be to do the second page of the handout. It says classwork May 20th at the top, and it does have both sides. You need to submit this on Schoology in some way, either a picture if you do hard copy, or through Note Anytime if you do it on the iPad. Then you also need to do a quiz. It's not a real quiz. It's just labeled a quiz on Schoology titled The Exit Ticket May 20th so that I can take a look and see how you're doing. And then please, if you didn't finish yesterday's classwork, you need to do the page 1 handout that says May 19th. And if you didn't finish the weekend homework, you need to finish graphing tangent. Good luck.